In the last video for section 3.2, properties of determinants, we're going to learn how to connect some of the theorems and definitions that you've learned in the previous videos to make a strategy to compute determinants. A strategy that's hopefully a little bit easier than trying to do a cofactor expansion. Here's the basic idea. We're going to use row operations to reduce a given matrix to an upper triangular matrix. And using the theorem that you learned in the last video, the determinant of the upper triangular matrix will just be the product of the diagonal entries. While we're doing our row operations, we're going to have to use the theorem from the beginning of the section in the first video to keep track of what's going on. We might have to keep track of row interchanges or multiplying rows by constants. So let me illustrate this strategy by computing the determinant of this 4x4 matrix. So here's where we start on the left. I want to use this 1 to create zeros below. So this is just like row reduction that we've done many times before. I take row 2 and I subtract row 1 to create a 0. I take row 3 and I add row 1 to create a 0 here. And then I have to subtract 2 times row 1 from row 4 to create a 0 here. So you do these operations, row 1 stays the same, and then you get a new second row, a 0, and then 4 minus 2, and then 2 minus -1, and 1 minus 0. And then you can think through how the rest of the new rows show up here. So now we have a 1 here with zeros below. The next thing I want to do, continuing with our row reduction, is to use this entry to create zeros below. So you might notice that when we're using this strategy, we don't have to create a 1 here, and we also don't really care about eliminating what's above our pivot position. We just have to make zeros below it. So in order to get rid of this 4, what I'll do is multiply row 2 by 2 and subtract. And then to get rid of this -2 on the bottom row, I'll just add row 2 to row 4. So work through those operations. The first 2 rows remain the same. The new third row is 0, 0, -1, 4. And the new fourth row is 0, 0, 1, -1. So notice we have zeros below here and also below here. And to finish off, to get an upper triangular matrix, we just have to make a 0 in this position. So in order to get that 0, I'll take this -1 in row 3 and add to row 4. So we do that final operation. The first 3 rows are the same. Our new fourth row has 0, 0, 0, and then 3 in the last entry. At this point, we have zeros below the main diagonal here, and above the main diagonal, we have any numbers we like, or anything that comes out of our row operations. So as we were working through this, you might notice that I said that each of these determinants were equal, and that's because we could use the theorem from the first video that says when we take a row and we add a multiple of another row, we don't change the determinant. So at each step, as I was working through, the determinant didn't change. But at the very end, our matrix, the determinant of our matrix, is quite easy to find because it's upper triangular. we just look at the diagonal entries and take their products. So we have 1 times 2 times minus 1 times 3. And then you just do the arithmetic and find that the determinant of our matrix is minus 6. So using this strategy, we can use row operations that we've done since the first day of class to compute determinants without doing a cofactor expansion.